Have you ever wondered why programming is essential for pentesters? Well, let's dive into that. Firstly, programming is the backbone of automation. With it, pentesters can automate repetitive tasks, saving precious time and resources. It's like having an army of diligent workers tirelessly performing tasks at lightning speed. Secondly, programming allows pentesters to create their own customized tools. No more settling for off-the-shelf solutions that might not perfectly fit the task at hand. With programming, you can tailor-make your tools to be as sharp and precise as you need them to be. Thirdly, programming enables pentesters to exploit vulnerabilities. It's like being a locksmith who can craft his own set of master keys. Once you understand the code, you can manipulate it to open doors that were intended to remain locked. Lastly, programming provides insight into the inner workings of different software. This understanding is crucial in anticipating and mitigating potential threats. Thus, programming is not just a skill, but a necessary tool for pentesters to excel in their field. Let's dive into some basic programming concepts that are pivotal for pentesters. First off, we have variables. Think of variables as containers. They store data that can be changed or manipulated throughout your program. For instance, you may have a variable named password storing a string value like QWERTY. Next, we have data types. These are the different kinds of data that can be stored in variables. Common data types include integers, floating point numbers, strings, and booleans. For example, the password variable we mentioned earlier is a string data type. Moving on to control structures. These are the decision-making elements in your code. If-then-else statements, switch statements, and loops are all types of control structures. They allow your program to make decisions and repeat actions. For instance, you might use a loop to try different password combinations until you find the right one. Functions are next on our list. A function is a reusable piece of code that performs a specific task. You could write a function to calculate the hash of a password and then call that function whenever you need it. This makes your code more efficient and easier to manage. Last but not least, we have error handling. This involves detecting and managing errors that occur during the execution of your program. Good error handling can mean the difference between a program crashing and a program recovering gracefully from an error. For instance, if a network connection fails during a penetration test, good error handling could allow your program to retry the connection or switch to a backup server. So there you have it. Variables, data types, control structures, functions, and error handling. These concepts form the foundation of any programming language and are crucial for pentesters. How do these programming concepts apply to pen testing, you might ask? Well, let's delve right into it. Think about variables. In programming, variables store information that can be manipulated or changed as needed. In pen testing, variables can be used to store sensitive information such as passwords, IP addresses, or other key data. This stored data can then be used in a variety of ways, such as in simulated attacks to test the security of a system. Next, let's consider control structures. Control structures guide the flow of a program, allowing for decision-making based on certain conditions. In the world of pen testing, these structures can be used to automate tasks or make decisions based on the results of a test. For example, if a certain vulnerability is detected, a control structure might trigger a specific response or countermeasure. Functions or reusable blocks of code are another key programming concept. In pen testing, functions can be used to create efficient, reusable pieces of code for common tasks. For example, a function might be written to scan a network for open ports, and this function could be reused whenever this task needs to be performed. And we mustn't forget about error handling. Error handling is crucial in programming to manage unexpected situations and ensure that the program doesn't simply crash when something goes wrong. In pen testing, effective error handling can help manage unexpected situations during a test, such as a system responding in an unexpected way, thereby ensuring that the test continues smoothly. Then there's the concept of loops. Loops are used in programming to repeat a certain action until a specific condition is met. In pen testing, loops can be used to automate repetitive tasks, such as attempting to crack a password by trying different combinations. So you see, the marriage of programming concepts and pen testing isn't just convenient, it's essential. Understanding how to use these concepts in pen testing situations can greatly enhance the effectiveness and efficiency of a pen tester. Now that we understand the basic programming concepts, let's look at the real power of programming in pentesting. Unleashing the potential of programming in pentesting is akin to giving a master artist a palette of countless colors. It allows the creation of powerful tools tailored to specific tasks, making the process more efficient and precise. Imagine being able to automate repetitive tasks, freeing up valuable time for strategic thinking and planning. Picture exploiting vulnerabilities with a script you wrote, custom-built for the task at hand. Envision analyzing complex systems and networks, all through lines of code that you control. These are not mere fantasies, but the reality of pen testing with programming. Programming is not just a skill, it's a weapon in the arsenal of a pen tester. It amplifies their capabilities, enabling them to probe deeper, strike harder, and secure better. As we can see, programming allows pen testers to take their skills to the next level. Let's recap what we've learned today. We started with the importance of programming for pen testers, acknowledging that it's more than just a skill. It's a key component of the cybersecurity landscape. And for pen testers, programming opens up a world of opportunities and possibilities. We then moved on to the basic programming concepts, where we discovered the bedrock of any programming language. We delved into variables, data types, control structures, and functions, among other things. Next, we explored how these concepts apply to pen testing. We saw how understanding the mechanics of programming can help us to exploit vulnerabilities, detect security flaws, and create more secure systems. Finally, we looked at the power of programming in pen testing. We realized that with these skills, we can write scripts to automate tasks, develop tools, and even create exploits. Understanding and applying these programming concepts will undoubtedly aid you in becoming a successful pen tester. Remember, programming is not just a skill, but a powerful tool in your pen testing arsenal.